Welcome students. In this video we will discuss Cambridge International Mathematics May-June 2023 and the paper code is 0607/42. So our discussion will be based on this paper, and with the help of this paper I will try to emphasize and concentrate on particular question and particular concept in each video. So let's start today's video. So the first question, as you can is see the first question is based on this sequence. So the question says, for each of these sequence find the next term and an expression for nth term. So we may predict this type of question for this year also. So I will try to summarize basic concept of sequence with the help of this question. We will also solve similar questions from previous year papers belonging to this sequence chapter, right? So the whole video will be based on this sequence topic, right? So first of all we have to study basically arithmetic sequence, arithmetic sequence. Then we have to study quadratic sequence. Then we have to study the cubic sequence. Then we have to study the geometric sequence and some other sequence, right? Arithmetic sequence, I can say this is a linear sequence. Why it is called linear, why it is called quadratic, why it is called cubic? So its simple explanation is its nth term. If you want to write its nth term an, so it will be a linear expression. You may write a plus n b, or you can write like this, an plus b, an plus b. Since this is a linear expression, so that's why it is called linear sequence. Similarly, if we want to write the quadratic sequence an, so it should be an square plus bn plus c, right? Similarly, cubic sequence will be written as an cube plus bn square plus cn plus d, right? And geometric sequence is how we can write its nth term. So its nth term will be written as an is equals to a r raised to power n minus 1. Let us emphasize these sequence in detail. So what is the arithmetic sequence? Arithmetic sequence is such that each number will get added by a common difference term, that is the d. So first term is a, so next term will be a plus d, after this a plus 2d, and so on. It will be written like this. So if you see the difference between consecutive terms, that is the t2 minus t1 is equals to d. If you see the difference between third term minus second term, still this difference will be d. So that's the arithmetic sequence, or you can say the linear sequence. So it means the first difference between the consecutive terms is going to be constant. The first difference between the consecutive terms going to be constant. That's a linear sequence. Let us see the quadratic sequence. What's the condition for quadratic sequence? The difference of difference. Let us suppose we have some term like a1, a2, a3, a4, and so on. So what's the condition is the first difference, that is the a2 minus a1, similarly a3 minus a2, similarly a4 minus a3. This is the first difference. This is not to be the constant. This will be not be constant. What's we have to take? We have to take next difference between these terms, and this is going to be constant. I hope you are getting this point, and you have studied this before also. This is the quadratic sequence. What I recommend is, here the second difference is equals to 2a. You may remember that its second difference term is equals to 2a. We can also find this. I will explain this also, but okay, you may remember that the difference of difference for quadratic sequence will be 2a. Similarly, if we see the cubic sequence, so its term, let us suppose a1, a2, a3, a4, dot dot dot. What's the condition is, you will get first difference, then second difference, that is the difference of difference, then you will get the third difference. So third difference will be going to be your constant. So here what we have to remember, the third difference is equals to 6a. So third difference that is going to be constant is going to be 6a, right? So if you remember these 2 points, your calculation, your answer will become fast. Okay, let us see this question first. So what it is saying, for each of these sequence find the next term and expression for the next term. So let us try to find its difference. So here the difference is what? See, we have to find second term minus third term. So here it is 14 minus 17. So basically we are getting minus 3. So here it's minus 3, so I should write minus 3. So it is minus 3. Again you can see here it's minus 3. It's my, since the difference of the consecutive terms, the first difference of the consecutive term is going to be constant. So this is the linear sequence, right? So you know the definition, the formula for this linear sequence also, you know this, that is the a n is equals to a plus n minus 1 into d. You have two approach. The first approach, that is the simple, you have the formula for its nth term, a plus n minus 1 into b. What's the a? A is your first term, this is our first term. What's the d? D is my common difference, d is my common difference. Here as we can see, a is 17 and common difference is minus of 3. So when we have to write its next term, simply the next difference will be still minus 3. So 5 minus 3, that is the 2. So the next term will be 2. If we want to write the nth term, so a is 17, so write 17 plus n minus 1, d is negative of 3. So just simplify this. So 17 minus 3n plus 3, so it is 21 minus 3n. So this is the first way, 21 minus 3n. If we want to see it's another way, so what we can see, what we can understand, see, since a general term for a linear sequence, if we write its nth term of a linear sequence, I should write a n plus b. Please see, in this approach, this a is not your first term. This is simple a polynomial expression like ax plus b. This is not your first term. So what we can get, the difference, I know the difference of consecutive term is going to be the common difference. So let us write its term. So what will be the first term? If you put n is equals to 1, the first term is going to be a plus b. If you write the second term, write its second term a2, put n is equals to 2, so it is 2a plus b like this. Write its third term, so it will be 3a plus b like this, and take the difference between consecutive terms. So always remember next term minus previous term, so a2 minus a1, so it is going to be 2a plus b minus a plus b. So b cancel out, it is going to be a. Similarly you can justify here also. If you see a3 minus a2, what it's going to be, 3a plus b minus 2a plus b. So again b cancel out, still this is a. So we get that the difference of the consecutive term is going to be a. So in this example, if we approach with the second method, what's the difference? It's minus 3. So I will write my a n, the general expression was a n plus b, where I get the value of a. What is my a? A is negative of 3. From where I get? I get from this observation. And you may remember this also, the difference, the first difference that is going to be constant is equals to a. What's a? A is not your first term here, a is your a n plus b, it's the coefficient of n. How we get the b? So see, first term expression, just equate this. You know the first term is a plus b. According to our calculation, my first term is a plus b. I know the value of a, that is going to be negative of 3 plus b. This is my first term, and according to question, this is equals to, the first term is 17, so just equate it to 17. So from here b is equals to what? 17 plus 3, so b is equals to 20. So you get the, that is the minus 3n plus 20. Oh sorry, it means here we have done something wrong. See, 17 plus 3, it's 20, not 21. So 20 minus 3 and 20 minus 3n, the answer is same. With this simple question I have explained the method for quadratic sequence and cubic sequence also. Okay, let us see the next part. We have to write its next term. First try to see what is going on. So it's not a arithmetic sequence, it's not geometric sequence. I can see here it is in the numerator, it is increasing by 1 1 1 plus 1. So the next term it should have 6 upon, in the denominator also, plus 1 plus 1 plus 1 plus 1, so it is going to be 6 upon 7. But what's the next term? See, my next term should be, see, if my denominator is n, then if my numerator is n, then denominator is n plus 1. See, 1 2 2 then 3. So if my numerator expression has nth term, see, its numerator has first term, the first term has numerator 1, the second term has numerator 2, the third term has numerator 3, so its nth term will have numerator n, and the denominator can be written in terms of n, that is the n plus 1. Are you getting this? Okay, the first term has the numerator value 1, the second term has the numerator value 2, so it's a simple logic. So this answer will be 6 upon 7 and this will be n upon n plus 1. Next, see, I think this is a geometric sequence. Each term is getting multiplied by 2. See, this is the into 2, this is the into 2, this is the into 2, this is the into 2. So the next term will get by multiplication with 2, so it's 128. So next term will be 128. And I want to explain that it's a geometric sequence. If the first term is a, the next term will get multiplied by some number. So next term will be ar. After this, you will get ar square, again multiplied by r, again multiplied by r, and like this. So what's the nth term will have? See, nth term will be, you can think like this. See, if this is the first term, it's r raised to power 0. If this is the first term, its power of r is 0. If this is the second term, power of r is 1. If this is the third term, power of r is 2. If this is the fourth term, the power of r is 3. So, and a is common to all the terms. So if you want to write its nth term, it should have a and r raised to power n minus 1. So that's the condition for its nth term. What's the r here? R is the common ratio. R is called common ratio. How we can find this? It's the ratio of the two consecutive term, next term upon previous term. So its second term is 8, previous term is 4, so it will 2. So we can write here its nth term as a. Here its a is first term. What's the first term? That is the 4 into r, that is the 2 raised to power n minus 1. That's the expression. We can simplify this a little bit. So we can write 4 into 2 raised to power n upon 2 raised to power 1 also, because it's, see, I can explain in detail. See, we can write 4 into 2 raised to power n into 2 raised to power minus 1, because in multiplication power gets added. So 2 raised to power minus 1 is nothing but upon 2. So it's 4 upon 2 into 2 raised to power n. So this will be simplified as 2. So we are getting as 2 into 2 raised to power again n. Again here it's 2 raised to power 1. So in multiplication with same base, power gets added. So it's 2 raised to power n plus 1. So it's better to write in simplified form 2 raised to power n plus 1. This is the complete C part. Let us see the D part. Again, let us see what's going on. It's not the geometric sequence. Let us see the difference. What's the difference here? This is the first difference, delta 1. So 5, what we have to do? Second term minus first term. So 5 minus of minus 2, that's the 7. Similarly, third term minus second term, that is the 24 minus 5, that is a 19. What's the difference of this? 61 minus 24, 37. And what's the difference of this? 122 minus 61, it's 161, right? Right. So as you can see, the first term, the first difference is not a constant, right? So what we will try to find its next difference. So again, 19 minus 7, that's the 12. 37 minus 19, it's again 12. 61 minus 37, I think, okay, there is a error in this part. So 37 minus 19 is going to be 18, and this 61 minus 37, 61 minus 37 is going to be 24. Again, you can see that here the second difference is also not a constant. So we will try for the third difference. As you can see here, it's the difference of 6. It's the difference of 6. So this is a cubic sequence. So please try to understand here. We have two approach to solve this question. Okay, the first approach is I want to discuss here. So after this, you may remember some terms also for easy calculation. So first of all, let us suppose its nth term of the cubic sequence is an cube plus bn square plus cn plus d, right? So what will be the first term? Or let us suppose, let us write its terms basically. What's will be the sequence? So when we put n is equals to 1, when we put n is equals to 1, here I am writing n is equals to 1, for n is equals to 2, for n is equals to 3, for n is equals to 4, like this. So for n is equals to 1, the term will be, I'm writing here the term, so the term will be a plus b plus c plus d. When you put n is equals to 2 in this expression, you will get 8a plus 4b plus 2c plus d. When you put n is equals to 3, you will get 27a plus 9b plus 3c plus d. Similarly, when you put n is equals to 4, we will get here as 64a plus 16b plus 4c plus d. These are the terms. These are the terms only, right? What we have to do? We have to take the first difference. So I'm going to write the first difference. That is the difference between these two terms. So this is going to be 7a plus 3b plus c. The difference between these two terms will be 19. Let me write clearly. This is going to be 19a plus 5b plus c, and the difference between these two terms is going to be 37a plus 7b plus c. Okay, so next find the second difference. So the second difference is going to be the difference between this and this. So this is going to be 12a plus 2b, and the difference between this and this is going to be 18a plus 2b. Next we will find the third difference. This is going to be the constant. As you can see here, the difference between these two terms will be 6a, and that's the constant. Why? Because see, the cubic sequence condition is the third difference will be a constant. So how we can find this? I was saying you that if you remember this third difference, if you remember this third difference for cubic sequence, that it is equals to 6a, you can solve this question very easily. That here I know, that the 6a is going to be 6. Why? Because my the third difference I'm getting as 6. So 6a is equals to 6, so a is equals to 1. So our general expression will have a is equals to 1. My expression was an square plus, sorry, a n cube plus b n square plus c n plus d. Here we get the value of a is equal to 1, so I can write n cube plus b n square plus c n plus d. So now to get this solution, I need b, I need c, and I need d. So how we can get these values? So since there are three unknowns b, c, d, we need three equations. So you can equate with any three terms, right? If you put with n is equals to 1, it should be equals to first term. You may put n is equals to 2, or in the simple term you may take the first difference. The first difference should be equals to 7a plus 3b plus c. You may remember the second difference, that is a 12a plus 2b, right? Here the I'm using my second difference, right? My second difference should be 12a plus 2b. So I will write 12a plus 2b should be equals to, what's the second difference according to question? It's 12. So I will write 12a plus 2b is equals to 12. I know the value of a is equals to 1 plus 2b is equals to 12. So 12 cancel out. So from here we are getting b is equals to 0. After this you may equate with the second difference. Okay, in the second difference you don't have c. We want c and d. So take the first difference. What's the first difference? It's 7a plus 3b plus c is equals to, what's the first difference was? First difference was 7. So write it 7 here. So we get the value of a as 1. It's 0 plus c is equals to 7. So from here again c is equals to 0. So c is equals to 0. To get the value of d, how we can get d? See, the first term is what? A plus b plus c plus d. A plus b plus c plus d is equals to the first term, and according to question my first term was minus of 2. So let us write it's minus of 2. A was 1, b was 0, c was 0, d we don't know is equals to minus of 2. So from here we can write d is equals to minus of 3. So we get the value of b, c, d. So my nth term should be equals to n cube, b 0, c 0, and d is minus 3. So a n is n cube minus 3. So we should write n cube, sorry, so we should write n cube minus 3. If you want to write the next term, either do the simple way, take the, here it's 6 6, so next term will also have 6. So 24 plus 6 30. So next difference should be equals to 61 plus 30, that is the 1 and 91. Then add 91 to 13 921 213. Or see, it's first, second, third, fourth, fifth, it's going to be 6 term, or you can use directly 6 here also. So if we substitute the value of n, that is a 6 cube minus 3, that is 216 minus 3, that is the 213, and we are getting the same value. So we have multiple approach to solve these type of questions. I hope you have understood this. Similarly, if I want to summarize for the quadratic sequence also, so my nth term will have an square plus bn plus c. So my terms will be, when we put n is equals to 1, it is going to be a plus b plus c. The next term will be 4a plus 2b plus c. The next term will have 9a plus 3b plus c. These are going to be terms. The first difference, that the difference between these two will be, it is going to be 3a plus b. The difference between these two will be 5a plus b. And if you take the second difference between these two terms, it is going to be 2a. And we should remember, I will recommend that you should keep in mind that the second difference is going to be 2a for the quadratic sequence, and for the cubic sequence it is going to be 6a. It will help you to find one variable. If one variable is found easily, other two variable will be easy to find. So if you have understood these concepts, so I will give you some questions based on these discussion, which is predicted for this year also. You may take the picture or snapshot and solve and try to find its solution. If you have any problem, you can comment below, right? See, this is the first question. You may take the picture and try to solve. This is the second question. This is the third question. These all questions are from the previous year examinations, right? Let us see the next. So this is the next question. This is the linked part from the previous question, so you may consider with the previous question. Next, see this. Next, this. Next, this. Next, this. Next, this is a good question. You should try. It may be that in the next video I will discuss some of these questions, because in this video already we have taken too much time, so I will discuss some of these questions in the next video. Let us see the next question. So this is the next, this is the link part from the previous question. So this is all about for your sequence part that is predicted for this year. If you have liked this discussion, please like this video, share among your friends. Thank you. Thanks for watching.